In the next bunch of videos, we're going to go through examples of U substitution, starting from really simple examples and building through more complex variations to see the range of things that we can kind of do with U substitution. All right, so we're at the top of page 600 in our workbook. So let's see what these examples look like. The first example is the one we tackled on the previous page, but I want to go through it to show you kind of how we would do it if we didn't have that first column to kind of already tell us what the answer was. So the first thing I want to do in U substitution is to, clues right there in the name, I want to define a variable called U that I am going to use to substitute in here to make a simpler expression, one that I do know the antiderivative of, because this is not on my table of antiderivatives. So what I'm going to do is I'm going to let U equal my inside function here, which is 3x. And now I want to figure out what du would be, which is kind of just taking the derivative of both sides. So du is equal to 3 times dx. All right, you see how I made that substitution, kind of taking the derivative of both sides, or the differential of both sides, I suppose, maybe? And so I want to rearrange this in a slightly different way just to make crystal clear what I'm doing here. I'm going to take this 3 and move it to the back of the expression. So this is going to look like cosine of 3x times 3 dx. And now I'm going to substitute u and du in for x and dx in this expression. And let's see what happens. So 3x I can replace with u. So instead of cosine of 3x, this is going to be cosine of u. And then 3 dx is what du is equal to. So see what this u substitution did for me. It took this modestly complex looking indefinite integral, something that I didn't automatically know the antiderivative of, to cosine u du. This is sitting right in my indefinite integral table. I absolutely know what the indefinite integral of cosine of u du is. That is equal to sine of u plus some constant. All right, so I had a little trouble finding the antiderivative when this was expressed in terms of x, but in terms of u, it became crystal clear what I needed to do. The last thing I'm going to do with this problem is u is just my invention. This problem was talking about x, so I want to make sure I get x's back in here. So I'm going to substitute 3x back in for u here. So this becomes the sine of 3x plus c. And we can double check our work just like we've always double checked indefinite integrals. I can take the derivative of this. I would use the chain rule for that and say, okay, well, it needed to be cosine of 3x. And then I needed to multiply that by the derivative of 3x, which is 3, which gets me right back to where I was before. All right. So there's the first example we have here. In the next video, we're going to tackle this second problem. Why don't you grab a sheet of scrap paper and see if you can calculate this yourself? It's going to be a very similar process. So see how successful you are with it, and then join me in the next video as we tackle it together.